Hi guys, Dhondee here, and on this video I'm going to show you how I make my project for EE278 for the field programmable gate arrays with the use of HCSR04 ultrasonic sensor with Altera Deo-Nano board. So these are the components and equipments that I'm going to use for this project. We have the power supply here, and the oscilloscope. We have some multi-tester here and some alligator clips. We have also some connectors. We have some resistor, the ultrasonic breadboard for testing, and we have the soldering stand for soldering iron. We have the soldering pump and universal PCB, and most importantly the Deo-Nano FPGA board. So that's it, guys. So this time, guys, I'm going to show you how I upload the codes to the Deo-Nano. So we have the ultrasonic.p. So in this code, this is a simple controller for ultrasonic sensor type. You can use either SRF05 or HCSR04. So for this project, I'm using HCSR04. So we have a clock here. We have the clock megahertz parameter, which is 50 megahertz by default. So the start here means that it launches a pulse measurement. So for the trigger, we have to be continued to the 3 pin of the sensor. So the trigger pulse parameter is 12 microseconds by default, and we have also the echo. So to be connected to the echo pin of the sensor. Then we have the new measure. So this new measure is 1 pulse if the measurement is complete, and we have the timeout here. We have also 1 pulse if timeout. If the timeout underscore ms parameter, we have the 12 milliseconds by default. And lastly, this distance row here means that to be read on impulse from new measure image data of the width of the echo signal encoded on 21 bits. So that's it about the ultrasonic codes. So this is the codes, and there's also comments here so that we can understand what it means. And then we have the top codes here, this one, guys. So now I'm going to compile it, and let's see if there are errors. So let's wait for a few seconds. It's running, guys. You can see here down, and also on the sides here on the taskbar, that it's running. Okay, we have also here, and then let's wait. Okay, it's running. That's it. Then since there are no errors, then let's proceed with the assignments here. Then you can click the pin planner, this one here. This is the pin planner for the project here. Then for the pin assignment, you can see this one on the user manual so that you will have a guide, and afterwards you can press the start IO assignment analysis. Then let's wait. After it is okay now, then we are going to click the tools. Then you go to the programmer here. So this is how it looks like. So first you can go to the hardware setup. By doing that, make sure that this is USB blaster. Okay, this is USB blaster. Then click the close. Then what you're going to do to ensure that the codes that you are using is the updated one, you can delete this one here. Then you can click the add file, then click the ultrasonic.sof here. Then after that one, you can press the start. Okay, then you can see here if it is failed or not. This time let's try it again. It is 100% successful now. The codes have been uploaded to the Deo-Nano. So that's it, guys. So now let's proceed with the testing of the project. So this is the setup for the testing of the project. We have the VCC trigger, an echo, and the ground connection here, as you can see on the video right here. So this is also when we check the trigger pulse in the oscilloscope. So as you can see, that is the pulse, and also we have a 5-volt supply for the ultrasonic sensor. So this is the setup. So this is now the testing of the prototype of the project. So as you can see on the screen, I'm going to upload the code now on the Deo-Nano. First, let me delete this one and change with this file again. Then hardware setup, make sure that it is USB blaster, then close, then start. It is successfully loaded, and as you can see